Okay, so these periodic functions, these fun little waves, which we're going to get into graphing. So first, what is a periodic function? Well, a periodic function is a function whose graph repeats at regular, oh, I don't like that thickness, hold on, regular intervals. Right? So the y values in the table of about, like if you were given like an x, y, t table, it's going to show a repetitive pattern happening over and over again. And that's like the wave effect of essentially like you're hitting this low point, you're coming back, you're hitting this high point, and then you're going to repeat. You're going to go back to the low point, up to the high point, and you're just going to keep continuing. Or the fancy word is oscillating. You are oscillating between the max and the min over and over and over again, right? And it's by the same increment every single time. So the period of a periodic function is how long it takes to complete one full revolution, right? From your starting point to the end, how long did that take for you to return back to your starting point, essentially, right? So that's the period of a function. Then if we're talking about the max and min point of this sinusoidal graph, we use trough to describe the minimum point, the trough, the bottom point. And our maximum point is called a peak, right? I've heard it also referred to sometimes as like the peaks and the valleys, right? Like the valley is the low point and the peak is like on top of the mountain, right? So you've got that. And then we have the equation of axis, also sometimes referred to as like the midline, which I'll like write underneath it. And it's really similar to like the axis of symmetry, like in a parabola, the thing that cut the parabola in half. This is the same dealio, but now you're going through the sinusoidal function. So it's cutting your function in half. It's the halfway between your maximum point and your minimum point. And you can algebraically solve for it on a graph because it is just your max point plus your minimum point, looking at your y values in particular, all over 2. So it's like you're finding the average distance between them. Coolio. And then last but not least is your amplitude. Amplitude is basically telling you the distance between the function's equation of axis or its midline, so the midpoint, to either the max or the min point. So it's like, what's the distance between those? And that is similar to the equation of axis, but you're going to subtract and do max minus min over 2. And that's how you can determine it. Coolio. So even if we have this graph here, and I were to ask you, like, what are all the key pieces of information? Here you are. Ooh, switch. Thank you. If I were to ask you all the key pieces of information of this sinusoidal graph, right? First, if we start with the period. So if I'm starting here at 1, how long does it take me to get back to 1 from its starting point? Yeah. 180, exactly. If I end up here, we notice here to here, that is 1 revolution or 1 cycle, and then you can see the pattern starts again, and it goes back into its wave. So 180 is the period. My trough is the midpoint, or like the minimum point, which I can see, okay, that's going to be, and I'll call this the period. This is going to be the trough, or your lowest point on the graph, which is at -2. And my peak, which is my highest point, right? That's going to be at 4. I told y'all, easy peasy, right? Amplitude, so we're saying, what is this distance essentially? That is our amplitude, the distance from here to here, which like you can even draw like a line. This will be your amp. Right, so then if we do A, or amp, is equal to max minus min, all over 2, we got that our amp is going to be, our maximum point is 4, our minimum point is -2, so we're going to do minus -2. Notice the double negative, and then divide by 2. This is really going to turn into 4 plus 2 over 2, which is 6 over 2, or 3, right? Which, okay, if I look at this graph too, I can see if I go 3 units up from this midline, or like from here, we can see, oh, there's a distance 3 there. And same thing, there's a distance 3 here. Unintentionally, we've also solved for the equation of axis here. We can kind of see it. Sometimes you can eyeball it and be like, oh, that's the line that cuts it perfectly in half. Or you can algebraically determine it. So I can say like equation of axis is going to be max plus min over 2. Or in this case, 4 plus -2, which is nothing fancy. That's just like 4 minus 2, which is 2 over 2, or 1. So even if you want to draw like a dotted line through here and show like this is the line, well, I should probably pick a different color since that's already light blue. I'll do green, right? This line that goes through here, this is our equation of axis, right? At y equals 1. So that's the line that cuts the parabola in half. And that's it. Those are your main characteristics of a sinusoidal function. We're going to use these characteristics later in the unit to build equations of sinusoidal functions. So does this model sine of x, or does this model cosine of x, right? How can we use these to articulate transformations of a particular graph, whether it's translated to the side, up and down, if the period has increased or stretched out or like become compressed, so you're doing more revolutions faster. These characteristics tell you that. So we're going to figure those out together later on. But we're just focusing on whether or not, like today, if we can determine if something is periodic or not, and then if it is, finding the characteristics. So even these scenarios, right, we have to consider whether or not it's periodic, and then if so, we have to state the period, the amplitude, and the equation of axis. So even for the first one, this is modeling the average number of hours of daylight over a 3-year period. Do we think this is periodic? Yes, it's got a repeating pattern. It's oscillating between the same max and min over the same amount of time. So I would say, yes, this is periodic. Ooh. Okay, so how long does it take to complete one cycle? What is the period of this function? Which I'm looking, okay, I start at 12 here, so when do I come back to 12? 365, right? That's really thick for this graph, but 365 days, exactly. So it takes 365 days or 1 year to do a full revolution, right? To end up back where we started. Okay, and then same thing, I gotta do amplitude, which is gonna be my maximum point, which what is my max here? 18, and my minimum point? 6. So I'm gonna do 18 minus 6 all over 2, which is just 12 over 2. Or 6, so basically that's 6 hours of difference is going to be my amplitude. And then my equation of axis, or my midline. That's gonna just be my max plus my min divided by 2. So 18 plus 6, which is 24 over 2 or 12, exactly. Voila, done, right? What about this one? This is the motion of a piston on an automated assembly line. Do we think this is periodic or no? Does it have a repetitive pattern? Yeah? Were you going to say yes? And no, it doesn't look like the pretty sinusoidal wave where it's constant, but it has a repetitive pattern where it is like starting here, it goes wishy-washy up, and then it comes back down, and then you notice at this time it repeats again. So because it has that repetitive pattern, it's considered periodic. Sinusoidal? No, but periodic, yes. So that's fine. So that's periodic. And then you tell me, what's the period of this function?
6.
Period. Yep, that's going to take 6 seconds. So equals 6 seconds. All right. Amplitude. I got to look. What's my max? What's my min?
Max is 1,
Yeah, and minimum?
-6.
Perfect. So we're going to do 1 minus -6 for the amplitude divided by 2, which this is going to become like 1 plus 6. So this is just going to be 7 over 2, or about 3.5, right? So that's my amplitude. And then I know for equation of axis, or my midline, we're going to do plus the 2 numbers. So we're going to do 1 plus -6, or 1 minus 6, which is going to give us -5 over 2. So about -2.5, right? So that's like the value, for example, if I went here on the graph, I could cut this perfectly in half. This is like my midpoint. That's the middle of the graph. That's what that means. And that's it. All right, and then the last one is a student moving a meter stick back and forth with progressively larger movements. So you can see it gets wider. Is that periodic? No, it's not a repetitive pattern. It's not increasing and decreasing by the same time. So this is not periodic. So we don't have to solve for anything here. Right? Coolio. And you can apply this. One of the most common things that you will encounter in sinusoidal functions when it comes to applications and word problems is the idea of a Ferris wheel. That is like the number one thing. A Ferris wheel doing revolutions over and over again models a sinusoidal function. So I took McKenna and Peniota, and they go to the Winter Wonderland Fair, and they see a Ferris wheel available to ride. But McKenna is scared of heights. So Peniota is going to go on it alone, and McKenna is going to watch her and model her height, right? So we can see this is the height of Peniota on the Ferris wheel. I'm going to draw it right here. All right, with a little ponytail. So that's her on the Ferris wheel. And we can tell how high she's going to be or how long she's going to be at a certain height for by looking at this graph. So even this one, what is the maximum and minimum height she's going to reach? 7 meters, and the minimum? 1, right? Which makes sense that it's 1, not 0. She's not getting on at the ground. Usually for a Ferris wheel, you have to step onto a platform first and then load up. So, okay, now that we know that, right? And I can even label this on our graph. This is our max. This is our min, right? How long does it take her to complete 1 full revolution on the Ferris wheel? 8 seconds. I know that's really fast to complete 1 revolution, right? So this would be considered our period for this function. So you could say even equals 8. And then in terms of a Ferris wheel, what is the amplitude going to represent? If we know the amplitude is from our midline to either the top or the bottom, and this is a wheel.
The diameter? The radius?
The radius of the wheel, right? So because we're looking at a wheel, if this is our midline, right? We're saying that the amplitude is from our midline up to like the max or the min, right? So this is going to be the radius of the wheel. The amplitude is the radius, exactly, of the wheel. So then if you wanted to know what the diameter is, you would just times that by 2. Right? And then looking, and just her first revolution, because we can see from this graph, she did 3 full revolutions. She did like 3 full rides on this Ferris wheel. Just looking at her first revolution, when will she have a height above 6 meters? We got to zoom in and see, okay, she hits 6 at like this point. And then when does she come back down to 6? At 5 seconds, right? So just from here to here, between 2 and 5 seconds, is she above 6 meters, right? So we can say, therefore, she will have a height above 6 meters between 2 seconds and 5 seconds. Is it 3? No. 5. How could she do it in 1 second?
3 and 5. No, it's 3.
Oh, I'm blind. 3 and 5. Now my eyesight's getting shot. 3 and 5. Thank you. And that is literally it. I told you it was eeny bitty, like tiny lesson, just looking at characteristics. The homework that I assigned for this is, again, practicing, identifying whether or not, hold on, people. Identifying whether or not something is periodic, being able to determine those characteristics, and then 2 different application questions involving a sinusoidal function or a periodic function. So you can work on these problems if you want to get ahead of it. You can start reviewing for your test that's Thursday. I'll give you the practice test. But yeah, otherwise the time is yours. And then like Friday, we can like review this or go over any homework, and then we'll start like 6.2 and get into it.